All right, objective 12 is going to be a Python-related vulnerability, a bit exotic one. So let's take a look at it. And for this challenge, we need to travel to a new location. And this is going to be a new island, the Film Noir Island. The location where I navigated my ship is the Chiarusco, or Chiarusco, I think it's pronounced Chiarusco. Get it because it's Film Noir. A portion of this island. And because it's a new island, don't forget to talk to the goose of the island here to collect the decoration for your ship. I'm gonna dock now. And on this portion of the island, we're going to have two different challenges. Here's the goose. It says moo. Okay. We have Wombly Cube here. We're not going to talk to him right now, but it's a very, very important dialogue. But we'll pick it up later when we're going to generate a synthesized version of the voice of Wombly to pass the challenge. I think I muted everything here. Strangely, I still hear the steps. Okay, I think it's just some weird overlapping maybe. All right, so the challenge that we're going to work on now is called Non, or Not a Number. 2 out of 5 Christmas trees, fairly simple one, but it's a very interesting challenge related to a vulnerability that is specific to Python, and it's a fairly recent discovery. If we talk to Shifty McShuffles, excellent name for the character, he's going to give us hints on how to beat him in a game. That's kind of weird, but it's what it is. So let's search for Shifty's name here. So the upper hand, we need to exploit a weakness in his algorithm and kind of get to an error condition where there's no validation in this game of well, playing. It's basically a card game. It's like the game where you need to guess the lowest number, but you need to guess 5 times, and the lowest numbers, if you guess the same one, will eliminate themselves. The highest ones will eliminate themselves. So either you have the highest or the lowest card, the most number of highest and lowest cards, then you're going to win, or if you tie, then you're just gonna get 1 point. But the goal is to beat Shifty in this game, and it goes up to 10 points. So if you always draw, you're not gonna pass this objective, you're not gonna pass this challenge, because you need to score and reach 10 points faster than he can. So first of all, let's just play the game and it will be clear how it works. There's the explanation here, and I do have burp running here in the background. So this is the card game game here, and this is the domain. So we need to guess 5 cards. I'm going to guess 9, 8, 7, and then 0 and 1 for the last one. I think this is a pretty solid choice. We play these cards and we tie with Shifty because he guessed 2. Okay, let's try to then a different strategy. So let's do 0, 1, 2, and then 9 and 8. So let's go for the lower one. The problem with this, if he plays the same cards again, which he almost does, then yeah, it's actually the same ones, then we're going to tie again. So we're not going to be able to progress like this. So what can we do? Well, We can observe the traffic. Let's do again 0 and 1, and then 9, 8, oops, 8, and then 7. And I'm going to intercept now this request so we can observe how it looks like. So this is the request, and we already tried this one. So what if I try to do like a negative number? I mean, -7 is definitely lower than 2. I'm gonna forward this, and then we get back this message that it requires 5 unique values, but was given -7, and so on and so forth. This error message is, by the way, displayed here as well. He laughs at us with our weak try, with our weak attempt to beat him in his own game. Okay, so let's try something different. 8 and 7, I'm always going to send in the same thing. But what if, instead of a number, I'm going to send in a letter? I'm gonna forward this, and we get back a nice big error message here. We can copy this, do the same transformation as always to get something readable here, and we get a Python stack trace here. This, by the way, also going to be displayed if I release this in the background, which looks really cool in my opinion. So the problem here is that there is some validation. Now in this case, because we passed on a character, we ended up with an error condition. So this validation is not flawless. You can see the logic here, how they validate these numbers. Now, the reference that we get in the hints is on NaN injection. And this is a very short article just explaining how sending in not a number values or reaching conditions where integers are validated against not a number might result in unexpected logic errors. They also have here some code examples. DuckTales is the name of the project where you can check out how this vulnerability works. In our case, it's pretty interesting. So okay, interception is not running. Oh, let's redo. Yeah, I want to do now 0, 1, 9, 8, and 7. I'm going to intercept this and play these cards, but instead of 7, so I tried negative numbers. I tried sending in a string, and so character. What if I try NaN? How's it going to be converted? You can actually go through the details of the validation here, but our character already passed, the X character that we sent already passed this validation and ended up here in the code. Now we don't really know what line 172 or 97 is in the code. We just got a portion of this code here with the error condition, but we can see how the numbers are added to a list, and then the elements of the list are compared here. So basically our non-value will be competing against the number 2 in this case. So if I release this, well, you can also check the end result of this request, but we get a different message now. So this means that it worked. It actually worked, and the non-value is validated against the integer, which is always going to win, always going to beat that last card. So we score points this way. And we can redo this whole thing. I tried to do this with repeater, and it was kind of flaky, so I'm sorry I have to do this manually, but only a couple more times. We already know what the formula is. So let's intercept this one, play the card, put none. It doesn't matter actually how the how you write none. And then let's do it. I need to do it 3 more times if I'm not mistaken. 0, 1, and then capture this, play it. I'm gonna replace this one, and we are doing well. 0, 1, 9, 8, 7. Intercepting again. And we can also, of course, try different values here. So I can also put their test, and this will still result in an error condition. So we really need none in this case. Want to show that. So let's redo this one more time, and then I'm going to let him tie with us just to be nice to this little elf. Okay, let's drop none here. Send it in. Okay, and the last one, I'm not going to intercept this one, just do a quick modification here. 8, 1, and 7. We can tie because he only has 1 point, and our score is 9. So we managed to win the game and complete the challenge with this interesting vulnerability of Python injection. If I could find the challenge here, also the achievement. And don't forget to talk to the little elf. We're not getting anything out of him as an extra hint or anything like that, but we did complete the challenge. So this was a pretty fun vulnerability. I was not aware of that this exists, and given how popular Python is, I can imagine that there might be a lot of applications out there with hidden vulnerabilities of some sort of non-injection. So whenever you encounter, for example, a Python backend, I think it's a good idea to test for this new type of vulnerability, which is still falls into the injection class. And it's, I think, been always in the OWASP top 10 list. The next one is going to be more of a blue team kind of challenge with writing some KQA queries. I did not use any of the AI tools. I just came up with my own KQA queries for that one. So we'll do a fairly quick walkthrough on that one. If you're interested in that, then see you in the next video.